Hello and welcome to Maths by SAS. This is my first lesson of D2, chapter number 2, exercise 2B. In this class, students will be learning and discussing practical application of linear equation in real world. Before going to the lesson, there are some key points that we need to understand. That what is the general form of non-vertical line equation of line, what are horizontal and vertical lines, what are parallel lines, and what is the role of gradient in finding the parallel lines. So these are the questions that have to be really clear to all of you. If you find any difficulty in understanding these all questions, I will be giving the link of the lesson in the description box so that you can watch and understand these all lessons properly, because lessons of mathematics are integrated with each other. If one link is weak, the other link will also be affected. So please watch and understand those lessons properly. Let's move to today's class. Question 1 says, let me read the question. Question says, the graph shows Khairul's journey when visited a friend in town C. During the journey, he stopped for the breakfast at the cafeteria, after which he continued to drive to town C. Okay, and the questions that we need to answer are: at what time did he leave home? How far did he travel before he reached the cafeteria? And find the gradient of each of the following line segments clearly, and what we have to state what each gradient represent. Okay, let's try to understand the question. That this journey graph is about Khairul's journey when he visited his friend in town C. Okay, during his journey, he stopped for the breakfast at the cafeteria. So this is the first place where he is stopping. So it means it's a place for the cafeteria. And after that, and when he stopped at the cafeteria at 11 o'clock, and the cafeteria is at the distance of 50 kilometers from the starting point, he stayed at this position from 11 to 11:30. So it means his stay at this place is for half an hour. And after 11:30, at 11:30 he started his journey, rest part of the journey, and he continued the journey till 80 kilometers. And at time 12 o'clock he reached at the destination. So I hope you are clear that the first part is at what time did he leave home. This is the place when he is leaving the home. So the time of departure, or A part is the departure time. Departure. Learn the alternative language as well. Is 10. How far did he travel before he reached the cafeteria? How far means that how much distance he has traveled. So if you look at the graph, we can see that from 0 to 50 is the point where he has stopped for the first time. So for B part, how far he traveled, did he travel before he reached the cafeteria? He traveled 50 kilometers. He traveled, very easy questions, 50 kilometers. And the last part says find the gradient of each of the following line segments and stating clearly what each gradient represents. Okay, C, the gradient of OA. We have to find what the gradient of OA. Now recall my previous lesson that in order to find the gradient graphically, what we have to do, we have to take any 2 points on the graph and we have to try to complete a right angle triangle. And the formula for the gradient is what? Ratio of rise to run, rise to run. And rise is always along which axis? Rise is always along y-axis, and run is always along which axis? X-axis. So I'm trying to create a right triangle here and see how many blocks are coming on the right side for OA. OA, the rise is having how many blocks? Rise is having how many blocks? Rise 10, 20, 30, 40 and 50. This is the rise side and this is your run side. And run side 10 to 10:30 half an hour, and till 11 half an hour, so 1 full hour. So rise is of how many units? 50 units. Upon run is 1 unit and 50. Gradient is 50. And one more thing that the question is asking, that we have to explain our answers as well. So you can see that this is the ratio of rise to run and rise to run, and the graph is about the distance and time. So each gradient will be representing speed. Okay, average speed. Gradient of AB. Second part is the gradient of AB. Now do observe graph carefully, that A to B is the line which is parallel to x-axis. This is the horizontal line, and all the horizontal lines have the gradient 0. So the gradient of AB equals to 0. And what does this represent? This represents the rest condition. Rest. Okay, and moving to C part, that is the gradient of BC. Now again we have to apply the formula, that gradient is the ratio of what? Rise to run. Rise to run. And for the rise and run purpose, what we have to do, we have to try to complete a right angle triangle along BC. Okay, we have to try to complete the right triangle along BC. So this is my run side and rise side. Rise side. Look how many blocks are in the right side: 1, 2 and 3. From 50 to 60, 10, 20 and 30, 30, and from 11:30 to 12, half an hour. Okay, let me make it little dark so that my students can observe this clearly. This is my run side and this is the rise side. Rise side is having how many blocks? 1, 2 and 3. That is 50 to 60, 10, 60 to 70, again 10, and this is 30 upon. Now I have to see the run side as well. From 11:30 to 12, half an hour. So 30 divided by 1 by 2, or 30 reciprocal will be there, and 60. So the gradient is representing average speed. Speed 60 kilometers per hour. So I hope you can see, students, that how we are integrating and applying the concept of the gradient to the journey graphs as well. So please watch and understand this lesson carefully. And moving to the next question. Let's read the question first. Question 2 says that Ethan cycled from home to the post office. On his way back, he stopped at the hawker center to have his breakfast. The distance time graph shows the entire journey. Okay. The requirement of the question is how far from his home was the post office, and the second is find the total time he stayed at the post office and at the hawker center. And then we have to find the gradient of each of the following line segments and stating clearly what each gradient represents. Okay, we have to find the gradient of OA, and then BC, then DE. Okay, let's talk about each part one by one. If you look at the graph, we can see that the graph is the distance time graph, and the total distance is 40 kilometers, and the journey, the time at which the journey is starting is 6 and ending at 12. Okay, And now we can see that some parts of the graph are the non-vertical lines and some are the lines which are parallel to x-axis. Okay, so let's begin with the question, how far from his home was the post office? So we can see the question says Ethan cycled from home to the post office. So it means this is the position for the post office. And so post office is in front of what y value? So that is 40. So the answer for A part is that the how far from his home was the post office. Distance between home and post office, between home and post office, 40 kilometers. Okay, then total time he stayed at the post office and the hawker center, total time. So let's read the graph carefully. First of all, this is the position of first stop, and let's see that what is the length of this stop. This rest or stop is starting at 8 and it's ending at 9. So for the post office it's 1 hour, and then for the hawker center the next one is the next stop is starting at what time? At point C, and let me read it. This is coming 10:30 to 11 plus half hour, 1/2 hour. So the total time he stayed, at post office and at the hawker center equals to 1/2 hours. 1/2 hours. And moving to the gradient of each part of the graph, gradient of OA, recall my previous lesson that how to find the gradient graphically. For that purpose, what we have to do, we have to complete a right angle triangle. Okay, and we have to take the ratio of rise and run. We have to take the ratio of the height and base of that triangle. Okay, and if we let me make it little dark so that my students can see it more clearly. O to A, ratio of rise to run, and rise is always along which axis? Y-axis. Rise to run, rise is along y-axis. So you can see that in the rise we have what distance? 40 upon run. Run is of 6 to 7 to 8, 2 hours. 2 hours, 40 upon 2, which is equal to 20. But if we look at the graph carefully, the graph is about the distance and time. So when we divide the distance by time, speed, every speed is equal to distance traveled upon time taken, distance traveled upon time taken. So 20 kilometer, gradient represents his speed, gradient represents his speed, which is 20 kilometers per hour. Gradient of OA, and then we have to find the gradient of BC. Gradient of BC, B to C gradient. Again formula will remain same, rise upon run, rise upon run. Okay, for BC, again try to complete a right angle triangle from B to C. Okay, from B to C, let me create a right angle triangle, and I have to take the ratio of rise and run here. Okay, and see carefully that how many blocks are coming in the right side and how many blocks in the run side. Okay, here we have 20 to 30 10 units, and 30 to 40 again 10 units, so total 20 units on the right side. And run side from 9 to 10 1 hour, and it's right in between, so one whole 1/2 or 3/2, and the line is in the falling trend, so gradient negative. So 20 divided by 3/2, or what we can do is that 20 divided by 3/2, or what we can do is that minus 20 multiplied by reciprocal, okay, and then minus 40 by 3. 40 by 3, I have to convert 40. 3 ones are 3, 3 threes are 9, minus, so minus 13 whole 1/3. Okay, this is the gradient of BC. Gradient of BC is minus 13 whole 1/3, and it's representing the average speed. Okay, and then the third one, DE, gradient of DE. We have to apply the same technique, that ratio of rise to run. And for the rise and run, what we have to do, we have to complete a right angle triangle. When I'm completing the right angle triangle here, on the right side, how many blocks are coming? On the right side, how many blocks are coming? Like this is 10 and this is 20. 20, and on the run side only 1 hour, 20 upon 1, and gradient will be negative because the line is having the falling trend, so the gradient will be minus 20. And these all gradients are representing the speed of the cyclist for this journey time graph. I hope you are clear about today's class. Please watch my lessons, like, share and subscribe the channel, and press bell icon to get the notification of every lesson in time. Thank you very much.